Did Aston Martin's Hungaroring filming day with Jak Crawford just expose whether Honda's Spec 2 engine can truly save their 2026 Zandvoort campaign? That session ran under strict FIA mileage caps to gather drivability data, not chase outright lap times. It marked the first real-world test of a redesigned pre-chamber and altered piston shape. Revised lubrication systems also turned a wheel in anger for the very first time. Honda's Shintaro Orihara confirmed the HRC Sakura factory achieved their internal development targets for this update, yet he deliberately withheld any official horsepower figure from the public record. Independent estimates suggest a gain of 20 to 30 brake horsepower for the new unit. These numbers remain optimistic speculation rather than verified performance facts heading into the Netherlands. We know the engine targets faster combustion through specific mechanical changes led by Sakura. Orihara even called the method kind of a secret before disclosing technical details via Yahoo Sports. The hybrid side of the power unit remains completely unchanged alongside this ICE-only upgrade. Combustion characteristics will shift significantly enough to alter car behavior in the cornering phase. This is not a simple plug-and-play upgrade guaranteeing immediate results on track. The gap between confirmed factory success and actual race competitiveness remains an open question, so why does this distinction matter so much for Aston Martin right now? The narrative frames this update as a potential turning point for their Constructors' Championship hopes. The team has spent large portions of 2026 languishing near the back of the grid. Orihara explicitly warned that introducing the Spec 2 engine requires more drivability work. They now know how to do it, but the process is not instant. That admission transforms a performance boost into a complex engineering challenge with uncertain returns. Every lap Crawford completed during that filming day carries enormous weight for the team. Was he validating a breakthrough or establishing a baseline for months of calibration? The answer determines if Aston Martin arrives at Zandvoort with a genuine weapon. They might instead bring merely a promising foundation that still needs significant building. Until cars hit the Dutch track, everything else remains educated guesswork wrapped in caution. Engineers understand exactly how much can go wrong when combustion changes mid-season. Real telemetry must tell the story before we accept any performance claims as truth. That Hungaroring session was never about setting benchmark lap times or proving raw speed against rivals. It existed solely to validate whether 3 specific mechanical changes could survive real-world track conditions without catastrophic failure. The redesigned pre-chamber aims to accelerate flame propagation inside the cylinder for more complete burning. Altered piston geometry complements this by optimizing the air-fuel mixture path during compression strokes. Revised lubrication systems reduce internal friction losses that previously sapped usable power at high RPMs. These modifications represent Honda's focused attempt to extract more energy from every drop of fuel. Crawford's role was strictly diagnostic rather than competitive during those limited running hours. Sensors captured thousands of data points on thermal management and oil pressure stability. Engineers needed confirmation that the new components interacted harmoniously under load. A filming day provides just enough mileage to identify glaring integration issues before race weekend. It cannot replicate the sustained high-stress environment of a full Grand Prix distance, yet it remains the only legal opportunity to test hardware outside official practice sessions. This regulatory constraint makes every minute of running exponentially valuable for development. Teams risk penalties if they exceed permitted distances or use promotional days for disguised testing. Aston Martin operated precisely within these boundaries while maximizing technical return. The choice of reserve driver over a race starter also signals the session's experimental nature. Crawford could focus entirely on consistent feedback without championship pressure clouding his inputs. His observations directly informed calibration maps loaded into the ECU before Zandvoort. Without this validation step, engineers would arrive in the Netherlands flying blind on critical parameters. They now possess baseline drivability data that simulator work alone cannot provide. Real asphalt exposes vibration harmonics and heat soak patterns that virtual models miss entirely. This gap between simulation and reality defines modern F1 power unit development. Honda's Sakura facility led this redesign effort with singular focus on combustion efficiency. Their engineers understand that theoretical gains mean nothing if the engine feels unpredictable to drive. Smooth power delivery matters as much as peak output for tire preservation and driver competence. Jerky throttle response costs tenths per corner, regardless of dyno horsepower numbers. The Spec 2 update targets exactly this balance between brute force and usability. Orihara's team knows previous iterations suffered from poor drivability despite adequate peak power. Fixing that flaw required rethinking fundamental architecture rather than tweaking software parameters. Physical component changes demonstrate commitment to solving root causes instead of symptoms. This approach carries higher risk but offers greater long-term reward if executed correctly. Zandvoort will reveal whether that gamble paid off immediately or needs more time. The Dutch circuit's unique banking and elevation changes stress engines differently than Hungary. Low-speed corners demand precise torque application where combustion stability is paramount. High-speed sections test top-end breathing and cooling system adequacy under sustained load. No single track validates an entire upgrade package comprehensively on debut. but Zandvoort provides sufficient variety to expose major weaknesses quickly. Engineers will monitor telemetry streams obsessively throughout Friday practice sessions. Any deviation from expected behavior triggers immediate investigation and potential mitigation strategies. Backup calibration maps exist precisely for such contingency scenarios. The team prepared extensively for both best case and worst case outcomes. Confidence stems from validated data rather than hopeful projections alone. That Hungaroring run transformed abstract engineering concepts into tangible performance evidence. Whether that evidence translates to championship points remains the central question. Picture this for a second. You are an engine designer who has just spent months reworking the fundamental architecture of a combustion chamber, and your boss asks if it works. But you can only answer with a confident nod because revealing the actual numbers would hand your competitors a blueprint for free. That is precisely the position Shintaro Orihara found himself in when discussing the Spec 2 power unit via Yahoo Sports. He stated plainly that making combustion faster is kind of a secret, yet he could disclose a little bit about the philosophy behind it. This selective transparency is not evasion, but calculated protection of intellectual property in a championship fight. Orihara confirmed on record that the HRC Sakura factory achieved their target for this update. Note the specific wording there. He validated hitting an internal benchmark, not matching a rival's dyno sheet. No official horsepower figure accompanied that statement anywhere in the public domain. The absence of a hard number is itself a data point worth analyzing. It signals that Honda measures success against their own development curve rather than external comparisons. Internal targets account for drivability, reliability, and thermal efficiency alongside peak output. A raw horsepower claim ignores these critical dimensions of real-world performance. Competitors cannot reverse engineer what they cannot quantify from press releases. Orihara's confidence stems from validated test cell results at Sakura, not optimistic projections. The facility operates under controlled conditions that isolate variables impossible to separate on track. Achieving targets there proves the concept works as designed in theory. Translating that validation to Zandvoort's unique demands remains the active challenge. His team knows the difference between laboratory success and competitive parity. The phrase "achieved our target" carries weight precisely because it avoids hyperbole. It grounds expectations in measurable engineering milestones rather than marketing narratives. Fans craving instant gratification may find this restraint frustrating. Engineers understand it as necessary discipline in a long-term development war. The Spec 2 engine represents one step in a continuous evolution, not a final destination. Orihara's measured tone reflects that reality without diminishing the achievement. He disclosed enough to confirm progress while protecting the secrets that enable future gains. This balance defines modern F1 technical communication under intense scrutiny. Rivals monitor every word for clues they can exploit in their own development cycles. Silence on specific metrics denies them that intelligence advantage. The truth of the engine's capability will emerge through lap times, not press statements. Zandvoort becomes the ultimate arbiter of whether Sakura's targets align with competitive reality. Until then, Orihara's confirmation stands as the only verified benchmark we possess. It tells us the engine meets its design intent without revealing where that intent sits relative to Mercedes or Ferrari. That ambiguity is intentional, strategic, and entirely consistent with how manufacturers operate in 2026. The secrecy protects not just current advantage but future development pathways as well. What matters most is that the team believes in the hardware enough to race it immediately after summer shutdown. That belief is built on data we cannot see but can infer from their willingness to deploy. Confidence without evidence is delusion. Confidence with withheld evidence is strategy. Orihara has chosen the latter path deliberately. Remember how this all started, with that urgent question about whether the Hungaroring filming day exposed a truth that could save Aston Martin's Zandvoort campaign. The answer lies in understanding what that test actually validated, which was strictly an internal combustion engine change with absolutely no corresponding hybrid energy deployment upgrades. This distinction fundamentally alters how we should interpret any performance gains heading into the Netherlands. Orihara warned explicitly via Motorsport, that introducing the Spec 2 engine means combustion characteristics will change significantly. He did not soften this assessment or suggest the transition would be seamless for drivers. Engine behavior will be changed in the cornering phase as well, according to his direct statement. That single sentence carries enormous weight for race engineers and drivers alike. Cornering stability depends heavily on predictable torque delivery from the power unit. Altered combustion timing shifts where peak torque arrives in the rev range. Drivers must recalibrate their throttle application points mid-corner to match new engine responses. This relearning process cannot be completed in a single Friday practice session. It demands iterative setup adjustments across multiple running periods. The hybrid system remaining unchanged creates an asymmetry between electrical and mechanical power delivery. Energy deployment profiles were calibrated around the old engine's combustion signature. Mismatched characteristics can cause drivability issues that cost lap time despite higher peak output. Engineers face the complex task of harmonizing two systems developed on different timelines. This is where the true challenge of the Spec 2 update reveals itself. Raw horsepower estimates ignore this integration complexity entirely. 20 or 30 brake horsepower means little if the car becomes harder to drive at the limit. Orihara acknowledged this reality by stating they probably need more work to improve drivability again. His honesty transforms expectations from instant success to managed progression. The team now knows how to do it, but knowing and executing are separate challenges. Zandvoort's banked corners amplify any drivability flaws through sustained lateral loading. Drivers cannot mask engine inconsistencies when G-forces demand precision steering inputs. This circuit exposes integration weaknesses faster than most tracks on the calendar. The filming day provided baseline data, not final solutions for corner phase behavior. Real competitive validation requires racing against others pushing identical limits. Until then, the gap between theoretical gain and usable performance remains unquantified. This nuance separates informed analysis from speculative hype surrounding the update. Fans expecting immediate transformation may misunderstand the engineering reality at play. Progress in modern F1 power units is measured in incremental steps, not leaps. Each step forward introduces new variables requiring fresh calibration cycles. Honda's approach prioritizes sustainable development over short-term headlines. That philosophy serves long-term championship ambitions better than rush deployments. The Spec 2 engine represents genuine progress within that framework. Whether it translates to points at Zandvoort depends entirely on how quickly the team adapts to altered corner phase dynamics. That adaptation timeline, not peak horsepower, determines the update's true impact.